Okay, hello guys. We are going to talk about section 2.7, finding the inverse of a function. So to find the inverse of a function, here's what you're going to do. You're going to change f of x to y, then you're going to switch x and y, and then you're going to solve for y. Okay, if you can't do that, okay, then the function is not going to have an inverse and the procedure ends. Okay, so let's go ahead and take a look at an example here. So in our first example, you have f of x equals 2x minus 8. So what we're going to do is we're going to change this f of x to a y. Okay, and then we're going to switch the x and the y. So this y equals 2x minus 8 is going to change to x equals 2y minus 8. And then we're going to solve for y. So we're going to add 8 to both sides. That's going to give us x plus 8 equals 2y. Then we're going to divide both sides by 2. Now, at this point, you could leave it like this if you wanted. If you wanted to break these both up, you would get a 1/2 x over 8 over 2. That would be plus 4 here. Okay, and then the way we notate an inverse function is like this. F to the negative 1, okay, that negative 1 right there, that means inverse x. So that means I'm doing the inverse, f to the negative 1x equals 1/2 x plus 4. Let's take a look at this next example. So we're going to do the same thing. Okay, here we have, let's see, y equals 3/4 x minus 6. So I'm going to go x equals 3/4 x. Oops, 3/4 y. Let's see, we're going to switch the x and the y. So x equals 3/4 y minus 6. And now I'm going to solve for y. So I'm going to add 6 to both sides. It's going to give me x plus 6 equals 3/4 y. Okay, then I'm going to multiply by the reciprocal here, 4/3 on both sides. Okay, that will get rid of the fraction on this side. Those 4's cancel, those 3's cancel. And then here I'm going to get, let's see, 4/3 x. And then that is going to give me, let's see, 4 times 6 is 24 over 3. And that actually should just be 8. So we're going to get f to the negative 1x equals 4/3 x plus 8. Okay, let's take a look at example 3. So we have f of x equals x cubed minus 27, make that a y. And then here we would go x equals y cubed minus 27. Okay, then we'll add 27 to both sides. That'll give us x plus 27 equals y cubed. Get rid of the cube. We're going to take the cube root of both sides. And we're going to get f to the negative 1x equals the cube root of x plus 27. Now I know 27 is a perfect cube, but this is connected to the x, okay, with the plus sign, so I'm not going to take the cube separately there. All right, so let's take a look at the horizontal line test. So just like the vertical line test tells us if we have a function, the horizontal line test is going to tell us if the graph has an inverse. So if I can draw a horizontal line through the graph and it intersects more than once, then that means we are not going to have an inverse. So let's see, if I take this graph and I go like this, I intersect this 2 times, so this would not have an inverse. Okay, no inverse. Okay, and then here, let's see. Draw a horizontal line. Okay, I only intersect the graph 1 time. Okay, I know here this looks like it's going horizontal, but it's not, it's just approaching horizontal. So then yes, this one has an inverse. And when something has an inverse, we say that that function is one to 1. Okay, so I just want to take a look at this previous problem right here. Let's take a look at the graph of that and see what that looks like. Make sure that we're okay there. So we got the cube root. So math cube root of x plus 27. I want to see what this graph looks like. All right, it's kind of a flat line. It doesn't look like it's exactly horizontal. Yeah, it's not exactly horizontal, so it looks like we're okay. If it were a horizontal line, then obviously would not have an inverse there. So we're okay here with being the inverse. Okay, next thing we're looking at is verifying inverses. So you've got two procedures for this. The first one, of course, is just to find the inverse of a function. Okay, the second one is to do a composition function, f of g of x and g of f of x. Okay, if you do that and you just get x remaining, then the two functions are going to be inverses of each other. So let's do that with example 1 and 2 here. We have, let's see, f of x is going to be 4x minus 7, so f of g of x means that we're putting this in here for this x. So we're going 4 times x plus 7 over 4 minus 7. Okay, so in that, it looks like these 4's will cancel. I'm going to get x plus 7 minus 7. Those cancel, and I'm just left with x. So f of g of x is x. Now I want to do g of f of x. So g of x, this would go in here. Okay, so you have x plus 7, so for that x, you would put 4x minus 7, and then you have plus 7 over 4. Okay, well, in here, that's plus 7 minus 7 cancels out. 4 and 4 cancel out. So g of f of x is also x, which means that these two are inverses. Okay, let's take a look at example 2. Okay, so for example 2, we'll go f of g of x. Okay, which means that this function here, x plus 5 over 9, is getting plugged into f of x right here for this x. So 5 times x plus 5 over 9 minus 9. Okay, now that's not going to cancel, so let's see. This 5 will distribute to the top. 5x plus 25 over 9 minus 9. All right, I can see enough from there. That's not going to become f of g of x. So these are not going to be inverses because it has to happen with both of them. So you're good to go there. Okay, so this is not inverses. If it doesn't work with one of them, it's not going to work with the other one. It has to work with both. And as you can see here, the next topic is the distance formula, and that is actually covered in section 2.8. So go on to my next video to see section 2.8.